So today I'm going to be talking to you a little bit about how measuring pastures is a lot like making a potjie course, in that your success often depends on the chef, his experience, and sometimes keeping it simple gets the best results. So everyone knows that the first step to making a good potjie is getting the fires started. And I found that with pasture measurement, it's often the same thing, in that we have to light a fire under our producers to get them started measuring pastures. The big thing is just that, as researchers, we often take the flamethrower approach. So we toss a whole lot of calibrations, different mixtures, species, when you should be changing it, how you should be managing it, what you should be measuring, and we often overwhelm our farmers. When what we should realize is that often a simpler approach also gets the job done, because a match could probably light the fire a lot better than a flamethrower. So let's talk a little bit about the rising plate meter in itself. So the rising plate meter is a pasture measurement method where we are actually measuring compressed pasture height and not really pasture yield. We then utilize this calibration equation to calculate what the pasture yield would be at that specific height. So I want you to think of your calibration equation in the same way you would of a potjie course recipe. Now what I generally do when I'm looking for a recipe is I immediately jump onto Google. The thing is just that if I was to simply type in potjie course recipe, it's going to toss out a whole lot of recipes. So I have to find some way of screening those recipes. And when you're looking for a calibration equation, you have to have the same approach. So the first thing is that I'll decide what kind of potjie I want to make, because I don't want to be using a seafood recipe to make, for example, a lamb potjie. And with calibration equations, it's pretty much the same thing. You really don't want to be using a calibration equation developed for a grass monoculture to measure something that looks a bit more like this, because that is going to affect how the rising plate meter sits on top of your pasture. The second thing is, if I open up a recipe and it's got 100 different ingredients that I probably can't find at my local shop, and it's going to take me 7 hours to prep, I immediately shut down. So I would much rather go for a simple recipe with ingredients that I understand and a recipe I can follow. And calibration equations are pretty much the same. So as researchers, we have a really strong focus on accuracy, and that can overcomplicate things. What we really should be looking at is keeping it as simple as possible while maintaining accuracy so that it can be practically implemented on farm. Now the last thing is, imagine my husband comes to me after we've made our potjie and he says, "Janke, you know what? This potjie is really bland." I don't go, "Alvin, you know what? It must be the recipe. Toss it out," or "We need to replace the meat's not spicy enough." No. What we do is we only slightly tweak the recipe by, for example, adding seasoning or chilies or whatever, and then we get our end result. And pasture measurement and calibration equations are very much the same. So if you find that a calibration equation is only slightly over or underestimating your pasture yield, you don't need to toss the whole calibration equation, because it might only be a temporary thing. So what I like to do, for example, if I find that my calibration equation during a specific month is slightly overestimating my pasture yield, I'll tweak my allocation per animal, and that'll generally have a knock-on effect on my other aspects that I use pasture measurement for example, fodder flow planning. Okay, so I want to have a quick chat about the calibration equations a lot of producers are currently using in our region. These calibration equations often originate from New Zealand in particular, and you have to understand exactly what you're calculating. So when they construct these calibration equations, they use samples that are cut to ground level, which means that if you plug in your pasture height, the value you get from that calibration equation is calculating total pasture mass above ground level. What you then have to do as a producer or operator is decide what residual you want, so what you want to leave behind once the animals have moved out of a pasture. You then have to take that residual amount, subtract it from the pasture biomass pre-grazing, and that then gives you available pasture yield. Now, I don't know about you, but that sounds very complicated, and I like to keep it simple. So what we generally do when constructing calibration equations on Outeniqua is we actually cut our calibration equations at 5 centimeter above ground level. So when you then plug in your pasture height into those calibration equations, the value you get is immediately the grazable pasture yield. So you are basically then cutting out this whole step in your calculations. Okay, the second thing I want to talk about is that a lot of the calibration equations that are currently being used were constructed for grass monocultures, usually ryegrass. The big thing is that these grass monocultures are relatively homogeneous structurally, so up until now it's been okay. The big thing is that a lot of our producers have started adopting pastures that look a bit more like this, so you'll have typically mixtures of herbs, legumes, and grasses, and these pastures tend to be a lot more heterogeneous in terms of structure and composition, both on a spatial and time scale. So we might need calibration equations that can handle these changes a bit more. Luckily for our producers, for 3 years we evaluated 2 different pasture types on the farm in a farmlet study. So the first was a plantain-based mixture, where we had plantain, red clover, and tall fescue. And the second was a chicory-based mixture, where we had chicory, hybrid ryegrass, and lucerne. And during that farmlet study, we actually drew up our own calibration equations. So what I want to do today is try and see whether we can make recommendations to our producers in the region in terms of how they could maybe implement these calibration equations on farm. So let's look at the calibration equations themselves. So for each of those mixtures, they had their individual calibration equations. For the research purposes, we constructed individual seasonal calibrations for each season during the 3 years. So that equated to 12 different calibration equations across the 3 years. Now this would be our gold standard in terms of accuracy, but it could be relatively complicated to implement on farm for certain producers. So what we wanted to do next is try and see, could we simplify them so that you wouldn't have to change your calibration equations so regularly. So the first thing we did was we combined data within year, and we then constructed 3 annual calibration equations for this particular mixture. We then thought, well, could we simplify it even further and say to the people, well, this is your calibration equation for your plantain-based mixtures that can be used across years and seasons. We did the same for the chicory-based mixture, but there we only had 2 years of data. The big thing, of course, is that not all farmers plant or producers plant these particular mixtures. So they might have different iterations, different combinations. So we thought, could we use the data to construct a more general equation or general set of equations that could be used across different mixtures, irrespective of their components. Still maintained our seasonal equations in this regard, our annual equations, and then at the end of it all, we would have one equation that could be used across forage herb mixtures, across seasons, and across years. And that would be seen as our gold standard in terms of simplicity. Now, often when in research we look at calibration equations, we look at the stats connected to the calibration equation itself. But that only really tells us how well the data fits our calibration cuts. And it doesn't give us a true reflection of how it might be over and underestimating yield across seasons and years. So what I then did is I took a bit more of a practical approach. So during that 3-year study, we were also intensively measuring pre-grazing pasture heights before we went into the individual pasture strips. So I then plugged these pre-grazing readings into all of those different calibration equations to get an estimated monthly pasture yield for each of the calibration equations. That estimated monthly pasture yield for each calibration equation was then compared to our gold standard, which is our species-specific seasonal equations, to see how the different iterations of the calibrations would be over and underestimating pasture yield during certain periods. And then at the end of the day, We hope to compare them in terms of both accuracy and simplicity and make a recommendation based on that. Okay, so let's start looking at those comparisons. And the first one we're going to look at is for the plantain-based mixture. So here we have the estimated pasture yield on a monthly basis during the 3-year period. And this is for the specific seasonal calibration equations. So here you would have 12 different calibration equations for a plantain-based mixture, and this is really our gold star in terms of accuracy. So what would then happen if we have 3 annual equations? So you would have a separate equation for year 1, one for year 2, and one for year 3. The first thing I noticed was that we were overestimating yield using these annual equations from the autumn of year 2 heading into winter of year 3. And my theory here is that the structure of the pasture was changing. So from a very dense herb-dominated pasture to a bit more open pasture where the grasses started making a bigger contribution. The second concern is the underestimation, quite dramatic during this 3rd summer over there. So the reason for that underestimation would have probably been during this period we saw kikuyu really starting to invade our pastures. So once again our structure was changing quite dramatically to a much denser sward, and it seems that these general equations simply can't take that into account. What's interesting is that when we then say, well, we combine all of the data across years, so you now have a single equation you use for plantain-based mixtures, irrespective of year or season, we pretty much get the same picture as with our annual equations. So if I had to decide between an annual equation or one equation for plantain-based mixtures on my farm, I would probably go for this equation, but I would be very cognizant of the fact that I was probably over and underestimating yield heading into year 2 and year 3 and make those tweaks to my allocation. So how did our general forage herb calibrations fare? When we consider a general forage herb calibration on a seasonal basis, so now you have 12 equations, but it doesn't matter how your mixture has been compiled, so the species don't matter, we actually get a really good fit. So I'm very happy with this kind of approach. What's interesting is that it does seem to be able to handle that kikuyu ingression in year 3, and we don't have combining data across seasons. We once again see that we would have those periods of over and underestimation heading into year 2 and year 3, even if we have annual equations. And once again, if we decide that we're going to use one calibration across years, across seasons, irrespective of the mixture we've planted, the fit looks as follows. So this is probably our gold standard in terms of simplicity. But again, be cognizant of periods when you might be over and underestimating heading into year 2 and year 3. Okay, so would we have a similar result with our chicory-based mixture? So here's again our gold standard. We have 7 seasonal equations for chicory-based pastures. What's a bit concerning is that when we start combining data across seasons, so now we have 2 annual equations, one for year 1 and one for year 2, there is a period specifically during the winter and spring of year 1 when we are grossly underestimating yield using this equation. Now the thing with this chicory-based mixture is that we saw much more dramatic changes in composition, which would have resulted in changes in structure. So for example, during this period, our pasture was mainly ryegrass dominant, and there was very little contribution made from the other components. Then it went to chicory-based in the summer, and it became quite balanced between the grass, the chicory, and the lucerne during that autumn. So it would seem that general equations can't take into account those rapid changes in botanical composition. Once again, if you were going to say you want to simplify your equations, you might as well then just go for one equation across years and seasons, rather than going with the annual equations. What's interesting is that when we look at, again, the seasonal herb equation, so now it wouldn't matter what mixture you've planted, we actually get a relatively good fit. But once we again start combining data across years, so now we have the two annual equations, our fit becomes relatively poor. And again, if we use one calibration equation, irrespective of mixture, season, or year, we get the following fit, so you might as well go with that equation rather than the annual equations. Okay, so that's quite a lot of graphs and a lot of data, but the big question on everyone's mind is obviously, which is our winning recipe? And here you really have to decide what your end goal is. So if you are someone who's very strongly focused on accuracy, I would say stay with the mixture-specific seasonal calibrations for plantain and chicory, respectively. However, if you are like me and you like to keep it as simple as possible, I would say go for the overall herb calibration. So you would now be using this calibration irrespective of the mixture you've planted, as long as it's forage herb based, irrespective of the year and irrespective of the season. What is important, if that you go this route, you as a manager have to be very aware of those little tweaks you have to make to the recipe as you go along. So I would say if this is your approach as an operator, utilize other tools as well. Look at your residuals, get into the field, see whether the cows are getting enough food, visual estimation, that kind of thing. And I would only recommend this for a relatively experienced operator. If you say, well, I want to have a slightly more balanced approach where I still keep it quite simple, but I want to maintain accuracy, my recommendation would then be to use the general seasonal herb calibrations I showed, because they do take into account changes in composition over years and seasons a bit better than the overall calibration equation. So what's the end message? Well, if you walk into a potjie course competition, you're going to get two kinds of people. You're going to get the guy who's got everything prepped beforehand. He's got little baggies with his spices and his veggies are all ready peeled, and he follows the recipe to the T. And he could make a really good potjie. But you might have Frikkie next door who gets there. His wife still has to go buy the potatoes. He pours a little bit of wine into the potjie when she's not looking. He has his little spices that he mixed up at home that no one knows what's in them. And he might get just as good a result as the guy next door who's doing everything right according to the recipe. And with partial measurement, it's a lot of the same thing. You as an operator have to decide what your goals are and what you're really comfortable with. So guys, keep it simple, measure those pastures, and enjoy your potjie course. Thank you.
In this presentation, I will be comparing spring planted to autumn planted Italian ryegrass, and the question, are different planting dates an option? Most temperate pastures are planted in autumn, and the question is, can spring planting of Italian ryegrass be done? And this would be to assist in reducing pressure on the autumn planting season, and can it provide an 18-month pasture? The next question is, which Italian ryegrass types can be spring planted? And the only types that can be spring planted are the obligate types that have a compulsory requirement for a large number of cold days for vernalization to take place. Let's look at the vernalization process. So it starts off with a leafy pasture. Then there is a period of winter cold, and the plants transition to the reproductive or flowering phase. Then the plants are exposed to increasing day length, and they then proceed to the full flowering phase, which means that obligate types only flower after going through a winter period. This table shows the reproductive tillers in a sward, And we would generally say that cultivars that are suitable for spring planting should have less than 5% flowering in the first spring or summer. And the ones that fulfilled that criterion are in the red boxes. So there were 7 cultivars that fulfilled that criterion, and also the yield criterion. That's why some of them that are showing 0 flowering are not in the box. Then normal flowering takes place in the second spring after the winter cold and with the increasing day length. So here, this is from cut 11 to 14, which was basically from September 2022, which is now the following year, through to January 2023. We also determined the flowering percentage from a population of individual plants planted in 2021. And here we had a slight discrepancy if we look at the 5% recommendation, and we had, for instance, for Bar Crespo and Bond, we had lower values in the sward rating than we did in the individual plant counts. And the same went for Inducer. We had higher ratings in the sward, as was the case for Yolandi, than we did in the plant counts. So for Inducer and Yolandi, the plant counts showed a low flowering percentage, while in the sward it was 10%. So 10% may still be an applicable value because that seemed to be sort of the discrepancy between the two methods, is that everything was similar if it was less than 10%. If we look at the total yield over the 16-month period, and this already answers the 18-month question, the trial did not last 18 months. It only lasted up to mid-January, which was 16 months. But the best cultivars produced around 20 tons dry matter in that 16-month period. Then there was a whole group of cultivars that produced between 18 and 19 tons, and then at the end here we have the group that produced lower than 17 tons and were significantly lower. Right at the end you can see a cultivar that only produced 6.1 tons AgriBoost, and that shows what happens if a facultative Italian ryegrass cultivar is planted as spring planting. Now we will look at some of the seasons, not all of them, but just some of them. So here we have the spring yield, including the establishment period, and it was quite a good yield in the first spring. So the best one, Sakari, was just over 6 tons. Then a whole group of cultivars, basically most of them were between 5.5 and 6 tons, so similar to the best producing one, and only 3 of the cultivars were significantly lower yielding. If we look at the first summer, then we already see that the cultivars separate out a little bit. If we go to the end of the graph, there were already 3 cultivars that had no yield or 0 yield in the summer. Then there were a whole group that had a lower yield. This was the highest yielding was Impact, and then these ones in the dark color were similar to the highest yielding cultivar. And important to notice that the best yield in the summer season was around 3.6 tons dry matter per hectare. So this graph shows the comparison of summer 2021-22 in the red bars versus the spring that goes just before in the green bars. So the yield of the summer is about 2/3 to a third down from the spring yield. In winter, the best yield was around 3.2 tons dry matter per hectare, and there was a whole group of cultivars that were between 2.6 and 3.2 tons, and then there were a few on the end which had a significantly lower yield. But this would now be 3 tons over a 3-month period, so basically on average a ton a month. Looking at the second summer, we had a yield collapse for a lot of the cultivars. So as I already mentioned, the last harvest was on the 12th of January 2023, so it did not continue beyond that. A whole lot of cultivars had 0 yield. These ones had basically an insignificant yield, which was less than half a ton in that whole time period from December to mid-January. There were 2 that had around 1.3 to 1.4 tons, but it is still a relatively low yield, and importantly, it did not continue after this. Looking at a seasonal mean yield of the best cultivars, so this is the mean of only the best cultivars, so that we can try and get a picture of what the seasonal yield distribution looked like. This is from the spring planted trial. The red is in red, so from spring 2021, which had that high yield, and then summer 21, autumn, winter, the second spring, which was lower than the first spring, and then the second summer, which was really very low, and nothing in the autumn, which would have resulted in a yield gap if you didn't have anything else in that pasture, any summer growing perennial component. Now we add the autumn of 2021. So an autumn planted trial planted in autumn 2021 is represented by the blue bars. And we can see, for instance, that the spring yield was exactly the same from the autumn trial and the spring established trial. The summer yield was better in the spring established trial, and so was the autumn yield for that particular year. On this particular graph, we then add the third trial, which is an Italian ryegrass trial planted in autumn 2022, represented by the yellow bars. And we see that the first autumn was actually really good for that particular trial. It was better than the spring planted autumn, which is in the red. Overall, that trial yielded very well, also in the winter and the spring, as it did in the summer and the second autumn. But if, for instance, we had a similar scenario in this particular trial as was the case in the 2021 trial with the summer and the autumn, then we would have ended up with a yield gap here in summer and autumn 23. In this particular case now, the autumn was really good, but if you can imagine if the blue bars would have been here, if the Italian ryegrass was the only component in that pasture, this would have resulted in a yield gap. Now, if we look at the perennial components, like for instance perennial ryegrass, what that did in the same time period and compare it to the Italian ryegrass, the perennial ryegrass is represented by the dotted lines, and this brown dotted line represents the perennial ryegrass trial planted in autumn 2020, and you can clearly see the good yield it had in the first year, then not so good in the second winter, and you can see it sort of levels out the yield going through the second and the third year. Then the green dotted line represents the perennial ryegrass trial planted in autumn 2022, and it has a comparable yield in winter and spring 22, as well as summer, but not so good in the autumn of 2023. If we now add perennial species like plantain and chicory, the solid lines, so this first one here, is solid line represents plantain, which was planted in autumn 2021, and the yield was exactly the same as the Italian ryegrass in that particular year, the blue bars, but it had a much higher yield in the summer of 21-22 than the blue bar Italian ryegrass, and higher than the spring established Italian ryegrass in the red bar. Then here we have another forage herb trial, and the purple line represents the chicory and the green line represents the plantain in that particular trial. So there is winter, good spring yield, and then it's responded phenomenally to the summer conditions, with the plantain giving a yield in excess of 9 tons and the chicory just over 8 tons, and the plantain also being higher in the autumn of 2023 than the Italian or the perennial ryegrasses. So the ryegrasses were not able to respond, even the perennial ryegrass in the dotted line, in the same way that the forage herbs could respond to those favorable climatic conditions. So to conclude, spring planting of Italian ryegrass can be done, but an autumn planting is still required because the trial does not last 18 months, because the winter and second spring are too low, because the second summer is very low and would need a summer active species as a component in the pasture. This corroborates with data from previous trials that were done many years ago, both at Outeniqua and at Sadara. So spring planted Italian ryegrass can mainly be used as a gap filler in spring and the first summer if there is a need to fill such a gap. So the idea of a second planting season to relieve the pressure on the autumn planting season should then rather be done with perennial grasses and forage herb species and not with Italian ryegrass. Thank you very much, and I would just like to acknowledge the pasture science field team who harvest these trials and collect all the samples, and the farm services team for their support. Thank you. Good morning. My presentation today is about tall fescue. Why consider tall fescue for but does the yield match up to perennial ryegrass? The data used in this presentation is taken from trials at Outeniqua Research. So let's look at the dry. So this is the second set of trials. If we look at this table, shows the results of flowering in the tall fescue cultivars for the trial planted in March 2020. And what I would like to point out is here is the first flowering period, which took place from 15 September through to mid-October, and 2 of the cultivars had a bit of flowering going to mid or late November. Generally, the flowering percentage was low in the first summer or spring, really it is, and especially for the cultivars Eastern, Quantica, and Royal Q. Then we come to the second spring, which is now October 2021, and there the flowering really occurred in a month, so from the beginning of October to the beginning of November. The flowering incidence was much higher, which talks to a colder winter with more floral induction, especially in the cultivar Royal Q and Tower, as well as Boschuk. This slide shows the flowering for perennial ryegrass for the trial planted in 2020. And in the top part of the table, we can see the first spring. So flowering commenced in mid-September for most of the cultivars and went through to mid-January for most of them, although there were some that had a shorter flowering window, for instance, like Legion and Platform. They also had a fairly low incidence of flowering. Then the bottom part of the table shows the flowering of the second year, spring 2021, where the flowering was recorded from the beginning of November through to December, and a few went through to January. This flowering window seemed to be more compact, which was probably related to the number of cold days in the particular winter preceding. Compared to the previous year, there was also, to some extent, a higher incidence per harvest. But what about the forage quality? So we've looked at the yield, but so we will look at NDF as the quality factor, since that determines. We did a digestibility calculation to determine the These are the mean digestibility values. Then it is important to also look at the rate of NDF digestibility, which now looking at this is the digest. If we look at particular cultivars and their digestible yield, this graph represents the digestible yield for winter for two tall fescue cultivars, namely Royal Q and Quantica, and two perennial ryegrass cultivars, Viscount and Governor. So what I would like to point out is that this is for winter 2021 and winter 2022. So in each pair of bars, the first bar is winter 21 and the second bar is winter 2022. So for Royal Q, winter 2022, the second winter had a higher digestible yield than the first winter. The first winter was in fact the same for all cultivars, be it tall fescue or perennial ryegrass, the same digestible yield. But the second winter, the perennial ryegrass cultivars had a much higher digestible yield than the tall fescue. This graph shows the digestible yield for the summer months for the same four cultivars, but for 3 summers, being 2020, 21, and 22. So in each group of bars, the 3 summers are represented by the 3 bars. And we can see overall the tall fescue cultivars had the higher digestible yield in summer than the perennial ryegrass cultivars. But I would also like to point out that the third summer for the tall fescue had in fact a higher digestible yield than the second summer, which shows that the yield stability of tall fescue. If conditions allow, the yield can improve again, whereas for the perennial ryegrass we see this decreasing yield trend regardless of the conditions, because these were for the same summer conditions. So the perennial ryegrass was unable to respond in that third summer to the improved conditions. To conclude, tall fescue versus perennial ryegrass, we can say that tall fescue has a higher dry matter yield than perennial ryegrass. It has a different seasonal yield distribution though, which is important to note. So it has a higher yield, especially in the warmer seasons. Tolfescu has yield stability over years, and importantly, it has a comparable digestible yield. So if we look at Tolfescu in pasture systems, what we can conclude and what is recommended is that Tolfescu should be used in combination with a low NDF species like red clover or plantain, for instance, and this would further have a positive effect on the digestible yield. The excess high quality yield in summer should be ensiled to feed out during the winter, since we know that the winter yield is lower than, generally lower than perennial ryegrass, or in most cases. And Tolfescu does not need annual oversowing. So this would mean reduced inputs in a system where Tolfescu is the base. It may need to be oversown at some stage with something that is winter active to improve the winter yield of the pasture, but this would not happen immediately after establishment, but in maybe in subsequent years. And finally, the cultivar choice is very important. Not all cultivars of Tolfescu are equal. I would like to acknowledge the Pasture Science Field team who take all the samples and harvest all the trials and make all this data possible, and also the support of the farm services team that assist with running these trials. Thank you very much.
This presentation is about supplementing Virginia mycin to cows grazing perennial ryegrass pasture during spring. There are many feed additives available on the market, and what is crucial is what is the cost versus the return on investment, because we do want to make more money when we use additives. And the question is, does it work for cows on pasture? Because many literature is available for additives fed to cows on a TMR system, but not that much on pasture. And when thinking of an additive, we need to know what is the mode of action. So in this instance, we want to have a look at the additive Virginia mycin, which is marked as Stayfac. It's a fermentation product of Streptomyces virginiae. It has antimicrobial activity against gram-positive bacteria in the rumen, and then reduces the lactate produced in the rumen. This should then stabilize rumen pH. In short, improve rumen environment, increase propionate, might reduce ruminal acetate, and also methane production. So the aim of this study was to determine the effect of Virginia mycin on milk production and milk composition of Jersey cows grazing perennial ryegrass during spring. This was only a production study where we used 40 cows, resulting in 20 cows per treatment. So our hypothesis was supplementing of Virginia mycin to cows grazing ryegrass will increase milk production or will increase milk fat content. The study was a randomized block design with two treatments and 20 cows per treatment. Cows were blocked according to milk production, days in milk, lactation number, and also milk composition. Measurements we took were milk production, milk composition, life weight, and condition score. The Stayfac was supplemented at 0.6 grams per cow per day, resulting in 0.3 grams per cow per day of Virginia mycin. We started off with 60 multiparous cows, selected from a herd of 240 cows as a pre-trial group. The cows grazed as one group. Then we took a composite milk sample of morning and afternoon milk a week before the final allocation. We used this to remove any high somatic cell count cows, and then we selected 40 cows and blocked them according to milk production, days in milk, and lactation number, and then they were randomly allocated to treatments. The concentrates were mixed by Nova Feeds, who ensured that the additive was mixed in very well. Something about the allocation of cows, this is quite crucial. We went to a lot of trouble to ensure that the allocation was done correctly. You can see in the top there's a milk production 7 days before the trial started, very similar at 22.48 and 22.47. Milk production 3 weeks before the trial started, also exactly the same or very much the same. Lactation numbers were similar. Days in milk at the start, 91 days for the control and 82 days for Virginia Myson. Live weight at the start, close to 400 kilograms for both groups. Condition score at the start, 2.35 for both. And we even looked at previous lactation, milk production, which was similar for the two groups. The milk fat of the previous lactation, this was now done with milk recording. Only afternoon samples were analyzed, that's why they're higher. It shows very similar for the two groups. And then milk fat percentage the week before the start of the study was a slight difference, but not really a significant difference, 4.55, 4.47 for the two groups. We used our 20-point swing over dairy parlor, which is a Waikato machine with an AFI milk management system, which works very well. Cows grazed on 10 hectare irrigated perennial ryegrass, and fresh pasture strip was allocated after each milking. Composition of the concentrates is as follows, as shown in table 2. It's a maize-based concentrate with 50% maize, some omni-chop, wheat bran, and the protein source was soya oil cake. And both mixes were close to the same, only the additive Stayfac added at 0.01% on an as-is basis. Looking at the nutrient composition, the same for both concentrates. Protein on an as-is basis, 12%, starch 43%, fat content 3.2%, and then you can see the calcium and the phosphorus levels. Feeding of cows and milk sampling. Cows grazed as one group, and fresh grass was allocated after each milking. Cows were clearly marked with color tags, and groups were separated before milking. The concentrates were weighed in plastic bags for each cow, using an electronic scale to accurately weigh 3 kilograms for each cow that was fed during each milking. Concentrates were fed during milking, and groups entered separately in the dairy. We had an adaptation period of 21 days, a measurement period of 40 days. Milk samples were taken weekly, 5 times during the measurement period, and it was separate morning and afternoon samples taken and analyzed separately. Looking at the results, the effect of Virginia Myson on production parameters shown in this table. Milk production 21.6 for control and 22.3, so there was a significant increase in milk production on the Virginia Myson group. However, fat-corrected milk did not differ, and this was due to the lower milk fat of 4.77 on the Virginia Myson group versus the control group that had 5% milk fat. Milk protein did not differ. Lactose, no difference. MUNs, no difference. And somatic cell count was excellent for both groups. Live weight at the start, around 400 kilograms. At the end, both groups gained weight, and there was no significant difference in weight gain between the two treatments. Condition score at the start and the end also shown there, but no significant difference in condition score between the two treatments. Looking at the composition of concentrates that were fed to the cows and as well as that of the pasture, you can see the protein of the concentrate was 10.5 and 10.4 for the control and the Virginia Myson concentrate respectively, and the pasture, focusing on the pasture, 17.3% protein, and the NDF of the pasture 44%, so it's a reasonably high quality pasture. The mineral content of the concentrates in the pasture. Want to focus especially on that of the pasture, where you can see there's an oversupply of sodium, extreme high levels of sodium in pasture. It's commonly found in our area. Copper only at 5.8 parts per million is deficient in the pasture, as is zinc and manganese. So these microminerals were supplemented in the concentrate to solve these deficiencies. So to conclude, supplementation of agenomycin at 0.3 gram per cow per day to Jersey cows grazing ryegrass pasture during spring increased milk production significantly. However, reduced milk fat, and this then resulted in no difference in fat-corrected milk production. Thank you. Hi, I'm Robin Meeske. This presentation is about moringa supplementation to Jersey cows grazing perennial ryegrass in spring. Moringa oleifera is a softwood native tree native of India, occurring wild in the sub-Himalayan regions of northern India. It has been known for many decades for its positive attributes. It does contain antioxidants and flavonoids that do have the potential to mitigate methane emission. There are many claims on the beneficial traditional medical use of moringa, as you can see on this slide, from stimulating hair growth, fixing your vision, normalizing blood pressure, having better blood sugar levels, better digestion. So there are multiple claims on moringa. But the question is, what is really in it, and why are we interested in this? So the product that we have used was basically moringa leaves. If you use moringa leaves, you need to see that the protein level is relatively high, between 25 and 27%. It does contain flavonoids, a substantial amount, and especially the flavonoid quercetin, which does suppress methane production as it decreases rumen protozoa and the methanogen population. And quercetin was found in dried moringa leaves at reasonable high concentrations. There was a study done in 2019 by Kekana, published in 2019 by Kekana. They fed 60 grams of moringa leaves to Jersey cows, but the cows were fed on lucerne and Erogrostis hay plus then a dairy concentrate. They found that milk production tended to increase from 15.1 to 16.8 when moringa was added. However, in this study, calves suckled on the cows during the day and then were kept away during the night. So milk fat was also found to increase by the use of moringa from 3.5 to 4.4, which is quite substantial. Although the 3.5 milk fat for Jersey cows is on the low, is very low. We normally have 4.5 to 5% milk fat in our cows. Milk protein tended to increase from 3.4 to 3.7. So the aim of this study was to determine the effect of moringa oleifera on milk production, milk composition, and then methane emission of dairy cows grazing ryegrass pasture. In this presentation, I'm not going to report on the methane results. So our hypothesis was that moringa leaves fed to cows grazing ryegrass pasture will increase milk fat content. Our treatments were: treatment 1, the control, 6 kg of concentrate containing no moringa, and treatment 2, 6 kg of concentrate containing 60 grams of dried malt moringa leaves. We had 34 cows blocked according to milk production of the previous 3 weeks, days in milk and lactation number. Cows within blocks were then randomly allocated to 2 treatments. This left us with 17 cows per treatment. We had an adaptation period of 14 days, followed by a measurement period of 46 days. We took composite milk samples 4 times during the study, during the measurement period, to determine milk fat, protein, and lactose, as well as MUN and somatic cell count. Live weight and condition score were determined at the start and the end of the study. And then we took pasture samples and concentrate samples to analyze. Cows strip grazed 9 hectares of irrigated perennial ryegrass. Fertilizer was applied at 33 kg in after each grazing in the form of 101. Concentrate was fed at 6 kg dairy concentrate per cow per day during milking. So it was 3 kg at each milking. 6 rumen fistulated cows were used for the rumen study and the Insacco digestibility study in a crossover design with 2 periods and 2 treatments. Then we did a rumen study. It had an adaptation period of 21 days followed by a measurement period of 7 days. Rumen samples were collected in different periods to determine volatile fatty acids, pH, and ammonia. Rumen pH was measured using the TrueTrack data loggers to measure rumen pH continuously with 10-minute intervals for 72 hours. And then we did an Insacco dry matter digestion study to determine what is the digestibility of ryegrass in Insacco. Composition of concentrates fed to Jersey cows is shown in this table. The concentrate had maize as its main energy source, some omnichop added and some wheat bran. Soybean oil cake was the main protein source used, and then added some minerals, magnesium oxide. So the moringa treatment had 10 kg of moringa per ton of feed mixed. Nutritional value of the concentrates were balanced to be basically the same, and the protein would then be 12.5 on an as-is basis or 14.1 on a dry matter basis. You can see the calcium and phosphorus levels for the concentrate. So what were the results? In this table we show the milk yield, milk composition of Jersey cows fed 6 kg of concentrate with or without moringa while grazing perennial ryegrass. Milk yield did not differ. Fat corrected milk did not differ. Milk fat percentage was reduced on the moringa treatment. It was 4.96 on the control and 4.67 on the moringa. And this difference was significant. Milk protein did not differ. Milk lactose did not differ, as MUN and somatic cell count also didn't differ between treatments. So why the lower milk fat? Looking at the rumen pH data from the TrueTrack loggers, one could see that the trend was that the rumen pH was lower on the moringa versus the control, which might explain lower milk fat values. The live weight before the trial was around between 372 and 382 kilograms, and the moringa group tended to gain more live weight than the control. The difference is not that big, and it's a short-term trial, but we did find that trend. Pasture quality. Pasture was reasonable high quality with an NDF of 41.3 and a fat percentage of 3.34. Crude protein of the pasture 18.1. Insacco ruminal dry matter and NDF disappearance of ryegrass did not differ between cows on the control or the moringa treatment. So moringa treatment did not increase digestibility of ryegrass. So to conclude, supplementation of moringa at 60 grams per cow per day to Jersey cows grazing ryegrass pasture during spring had no effect on milk production, milk protein, somatic cell count, or milk urea nitrogen, but it reduced milk fat and it tended to increase live weight gain. Thank you.
My name is Bertus Meiberg, and today I want to speak about the Outeniqua beef production system here on Outeniqua Research Farm. Our beef platform is currently 24 hectares. 20 hectares are dry land with mixed pastures, and the 4 other hectares is under irrigation planted with lucerne, plantain and red clover. Our herd consists currently of 29 cows and 27 calves. There's also 24 other calves that we're busy finishing on the 4 hectares of irrigation. Separate from that, we've also got 3 F3 bulls that we bred out of the Angus herd on the farm. In that picture, you can see one of the bulls that we bred out of our herd. The picture shows a cow T44. She's 11 years old and calved 9 times. She's one of 2 cows from the original, when we started the herd, one of 2 cows that's 11 years old in the group. The grazing rotation on the 4 hectares irrigation is 42 to 45 days. On the 20 hectares dry land are divided into 1 hectare camps, and we use 10 hectares per group of 14 to 15 cows. The rotation per camp is 10 to 15 weeks, and the cow stays in one camp for 1 to 2 weeks per camp, according to the availability of pasture on that camp. The fertilizer on the 20 hectares dry land is done once a year from October to December with 28 kilograms of N per hectare. On the 4 hectares irrigation, we also do fertilizing of 28 kilograms of N per hectare after each grazing, and that is done about 7 times per year. The weights of the herd are as follows. At birth, the heifers usually weighs around about 33 kilograms and the bull calves 36. At weaning, at 6 months of age, we reach a target weight of 220 to 240 kilograms per animal. From 5 years onwards, we fortunate to have that we reach a live weight of 530 kilograms per animal. And there also you can see at 7 years it can also go up to about 600 kilograms. Here is a graph showing the weights against the age in years. You can see at 5 years of age it reaches an average weight of above 500 kilograms, and it will stabilize until age 11 years. It can go up to 600 kilograms per animal. Our mating season starts from 1 October. The F3 bulls are put into the herd on the 1st of November. We take the bulls out on 15 December, where after pregnancy test, the first pregnancy test that's being done in end of November. All animals not pregnant from first AI we test again at the end of December. The final pregnancy tests are done during February. And then all animals not pregnant in that last pregnancy test will leave the herd in February. Our calving date is from July to August, September, and we want to wean the animals, the calves, at 6 months of age in February. Just to show you what has been done in the past couple of years, the season of 2021, we had 30 animals that was pregnant. We sold 2 pregnant cows that calved out of our season. That left us with 28 animals that calved down, which we had 13 heifers and 13 bulls. 1 bull was kept back as a F3 generation bull to use in the future herd. 2 cows calved with dead that calved down with dead calves that were struggled to give birth. In 2022, the cows were put into 2 groups. We AI'd once. So the first group, we took 14 cows that calved first in the season, and we did a seeder program with them. 10 of the cows got pregnant from AI and 3 pregnant from the bull. 13 cows that calved later were directly put to a bull, which of 11 were confirmed pregnant. 7 heifers were also AI'd, which 4 were pregnant from AI and 2 were pregnant from the bull. 3 heifers also that the 3 heifers, there was 3 red heifers that we also put to a bull. All 3 of them were pregnant, but because of red and not fitting into our herd, we sold them as pregnant heifers. So in the end, with the seeder program, we were lucky to get a 67% pregnancy rate on first AI. In the end, 89% cows were pregnant from AI and the bulls. So in the season of 2023, we started with 37 animals in the group. 32 animals in the end were pregnant, 14 from AI and 18 from the bull. We sold 3 pregnant heifers, as already mentioned. That was pregnant from the bull. It were 3 red Angus heifers. We also sold 5 animals that were not pregnant. So that left the group with 29 pregnant animals, which 27 animals already calved. So in this picture, you can see the AI bull that we used, Spring Grove overall, and we used this particular bull for its calving ease, birth weight, and milk production. We also do vaccinations on 4, 5, 6, and 7 months. It's very important to do the vaccinations to look at the health, to make sure that the herd stays healthy and free of any diseases. We also do yearly vaccinations with lumpy skin and supervax for anthrax, botulism, and blackwater. We also do PM and TB tests yearly on the herd to test against contagious abortion, which is very important to test again and to make sure that the herd is healthy as well. We also did a trial into 2022 with 24 calves. We took 24 winning of calves at winning and put them on the 4 hectares of irrigation and tried to take them until finish to see what the difference in weights and at the end if there's a possibility for more income or potential more income on the calves. We did this trial to see maybe if there's a downward in weaning prices of the animals, if there's other possibility to keep the calves and maybe in the end get more income. So in the end, we took 12 calves in a group, which were randomly chosen, and 12 calves were rotating on 2 hectares of irrigation. 2 hectares were planted with lucerne, plantain, and red clover, and the other 2 hectares were planted just with plantain and red clover. Both groups were supplemented with mineralic, and also during May to June, we supplemented them with a 50-50 maize and bran mix during the time that the pastures were slow and we were shortage on pastures during the winter time. Table 1 shows the birth weight, weaning weight at 6 months of age, and the average daily gain from birth to weaning of Angus calves allocated to be finished on lucerne, plantain, clover pasture, and plantain clover pastures under irrigation. Here you can see a weaning weight at 6 months of 220 to 240 kilograms per animal, and all of them had an average daily gain of 1 kilogram growth per day. Table 2 show average live weight at weaning, finishing, average daily gain, average finishing age, and average daily gain from birth to finishing of animals on lucerne, plantain, red clover pastures, and plantain red clover pasture. Here you can see where the two groups were allocated to the two different pastures, pasture mixes, at a weight that was at the weaning weights that was between 220 to 240 kilograms. The weight at finishing for all animals ended up just above 410, an average of 410 kilograms per animal for both groups. We had an average average daily gain from weaning to finish on the lucerne plantain red clover mix was 640 grams per day, and the average on the plantain red clover pastures was 650 grams per day. This was done at the finishing age between 16 and 17 months of age, and that ended up in an average daily gain from birth to finish in the group of the lucerne plantain red clover mix, an average of 770 grams per day, and an average daily gain from birth to finishing for the group on plantain red clover ended up on almost 800 grams per day. Table 3 shows the pasture quality composition as a percentage of dry matter of lucerne, plantain, red clover pastures, and plantain red clover pastures collected from March till November 2022. 18 samples per 2 hectare camps were taken over this period, and it shows that I only want to highlight the dry matter, the protein, and the NDF percentages, and it shows that in both groups the quality or the pasture quality of both the mixes were comparable to each other, and that the pasture quality was quite good in both the mixes. When to market your animals, at weaning or at finishing? But I want to say that every farm is different, so each farmer must decide for himself and make his own sums when to market his animals. For us at weaning, marketing our animals at weaning at 6 months of age with 220 kilograms to 240 kilograms, we were fortunate to get an average of 8,000 to 9,000 rand per animal. When we took the animals till finishing on 16 to 17 months of age, with a 440 kilogram live weight, a dressing percentage of 55 or more, and we slaughtered 14 oxen which graded at A2 grade, all the carcasses, and we were fortunate to get between 12,000 and 13,000 rand per carcass. On the picture, you see 3 animals on the point of finishing and on the point of being slaughtered, and on the right hand side a picture of the carcasses of the animals. Looking at the potential income on a 20 hectare farm, it is easily, this table shows that we easily had 1.5 cows per hectare on the 20 hectares with the 30 cows. And then we market calves at 6 months. So each farm must decide for himself how many animals he wants to put to the market in each year. So here we did the sums. If we sold 5 cows 9 heifers and the 14 oxen. In the end, we had a total income of almost 220,000 rand, which gave us an income in rand per hectare per year of almost 11,000 rand. When we took off all the expenses, we ended up with a potential profit per year of almost 200,000 rand, which gave us a potential profit per hectare per year of just under 10,000 rand. If we take the calves down right through to finishing, we did the sums as well, and we got a 8,400 rand for a weaner calf with a weaning mass of 240 kilograms, a finishing mass of 440 kilograms, gaining a weight gain of 200 kilograms and a carcass weight of 242 kilograms. That gave us an income of 13,000 rand. When you took that off then the expenses, which mostly is pastures, and we took pastures at 2 rand a kilogram because fertilizer prices are high and also of irrigation. We ended up with deducting all the expenses. You can get an additional profit per calf of 550 rand. That will give you a profit per hectare for 6 calves per hectare of just over 3,000 rand. Comparing the 3,000 rand with the nearly 10,000 rand, it shows that it actually is, for us, it's better to sell the weaner calf than to take the calves right through till finishing. In conclusion, on our farm in the George area, you can easily get a stocking rate on a dryland beef farm of 1.5 cows per hectare. You must aim for a weaning weight of 220 to 240 kilograms. If you sell the animals at weaning, this is a low risk and a high profit system. If you decide to sell it at the finishing, sell the animals at finishing on irrigated pastures, that will go on to a high cost, low additional profit. But this can be overcome by planting more legumes and try to increase the average daily gain. And then you must reach a target live weight of 440 kilograms per animal at finishing. Thank you very much.